right, so now what we're going to do is apply the error bound for trapezoidal and midpoint. What we want to do is actually find an n to make sure that the calculated error that we calculate will be less than 0.00001, which means we need, starting for our E of t, this to be less than 0.0001. So we don't want our bound to go over that. And if we know our bound doesn't go over that, well, we know our calculated error won't either. So now if we plug everything in, and this is the same problem we did before, so our derivative here would be negative 2x sine x squared, and then we would get negative 2 sine x squared minus 4 x squared cosine of x squared. So we have to use product rule on that one. All right, and then now we can do the same stuff we did before. So we need to make sure that we find our absolute value of f double prime of x, and that needs to be less than. And if we go back and calculate it the same way, we know that this is an absolute value of this, and we get a negative 2. Sine is not getting bigger than 1 or less than negative 1, depending on the calculation you want to do here. So we can go from negative 1 or 1, whichever would make it bigger. And then x squared, I'm picking everything positive because we have a minus and a minus here, so no matter what, they're going to be added. You could even just throw them away if you wanted, or make them positive. It would give us the same thing because of the absolute value. The whole thing becomes positive, not just the parts. All right, so x squared is going to be biggest at 1 because we're going from 0 to 1. Plugging those numbers in, 1 will give us the biggest. And cosine again is 1. So this would be 6. So 2 plus 4 is 6. That's the biggest. And again, you can use your calculator. And if you plug this in your calculator and you graph it by going window 0 to 1 and then doing zoom 0 to fit it, it will then graph the highest to the lowest point. So going to your window will tell you the highest point is negative 3.844. So you could just say 4. 4 is the biggest that we could actually have. 4 would give us something that's a lot more precise. But we're going to keep this the purely non-calculator way so that your answer comes out the same as the books. But I would use 4. All right. So we know that our second derivative must be less than 6. So now if we plug this in, we know that our E sub t must be less than or equal to f double prime of x b minus a cubed over 12n squared. And so this must be less than or equal to 6, right? 1 minus 0 cubed over 12. And now we don't know the n squared. But remember, our error bound must be less than 0.0001. So if this is our error bound, right, then it must be less than this number as well. And so now we just need to solve this. So this will become 1 over 2n squared. So 2n squared is positive, so multiplying it to both n sides would not change anything. So 2n squared, and we end up with 1. And then 0.0002 n squared. And now you could have also just said, well, this right here is 1 over 1,000, or sorry, 10,000. And then just said 2n squared equals 10,000 and go from there. But I'm already here. So now we're going to divide both sides by 0.02. And again, make sure you don't introduce a negative. You introduce a negative, this flips. So as we're adding, subtracting, multiplying, and dividing, if you multiply or divide by negative, inequality flips. All right, so we're going to go 1 divided by this. And we get 5,000. All right, and then we only can keep the positive. So we take our square root. So n is greater than. And then we plug it in the calculator. So we take this one and we want to square root it. So square root, second square root, plug that in, hit enter, and so we just say 71. So our n must be greater than 71. Because you can't use n of 70. 70 would not work, so it has to be 71 to get there, because we have to go bigger than this number. So bigger than 70.71, 71. So we need to do 71 subintervals here in order to get an accuracy of 0.00001. Now let's do it again with midpoint. So it's the same thing. We're going to go error of midpoint is less than, and now we're just going to plug it in. 6, oops, we should probably write it out, huh? Second derivative of x, b minus a cubed, all over 24n squared. Remember, it's double. Well, sorry, half. The e to the t is double the e to the m. All right, so now this would be less than or equal to 6, and then 1 minus 0 cubed over 24n squared. So we're doing exactly the same thing, but this time with twice as much. So 6 into 24 would be 4n squared. So 1 over 4n squared. And so this would be 1 is less than 0. Let's do it differently. Why not, right? Yeah. So 1 over 4n squared is less than 1 over, and then 1, 2, 3, 4. So remember, 4 decimals, 4 zeros. And now you can see that they're equal because the numerators are the top. Numerators are the same, so the denominators have to be the same. However, it's an inequality, so denominators are backwards. So this would actually become 1,000 for n squared. You can also just think of cross multiply. So that would have to go over here. The reason is with denominators, remember, the bigger the denominator, smaller the number, smaller the denominator, bigger the number. All right. So in order for this to remain smaller than this one, because that's how the inequality is written, your n would have to be bigger. So the 4n squared would have to be bigger than 10,000 for this to remain smaller. All right. So now we divide by 4. I guarantee you probably like the other way better. And so n here must be greater than or equal to 20 to 50. And so there you go. Now, if you were going to use your calculator, then all that would do is change that 6 to a 4, and it would give you something a lot more precise, so you wouldn't have to pick your n to be so big.